Hello, this is John Murky, co-chair of the IHE ITI Planning and Technical Committee and employee of Bylight Consulting. This webinar is going to be on the IHE's document sharing, and it's going to include the FHIR version of that. So the agenda today is background on document sharing, giving you some idea of the FHIR methods that IHE has provided to document sharing, including some support profiles as necessary, and then introduction to this MHDS, which is a full FHIR stack solution for document sharing. And then we're going to finish up with consuming data elements and resources rather than just documents, and how through Provenance you get back to the source documents, providing a full support for all of the capabilities of documents. So first off, what is document sharing? So document sharing is depicted here. It's made up of some kind of community that have come together for the purposes of sharing documents. In this case, it's a clinical setting, probably a health information exchange in a region. It's made up of primary care physicians and labs and public health and pharmacy, including the patients themselves in some cases. It's made up of some central infrastructure which provides the trust framework, provides some identity management framework, and it provides a document registry that holds the metadata that you will see. And then there is a set of repositories that are associated with each of the participants within the community. Those repositories could be distributed as shown here, or there could be one or more in the central infrastructure. So document sharing has been around for a while. The cross-enterprise document sharing, XDS, is the original profile produced back in 2004. It is based around some W3C standards. It's based around EB Registry, SOAP, and SAML. And it does include a patient identity management solution based on HL7v2 or v3. And it does support a centralized set of registry and potentially distributed repositories or centralized repositories. And the users are federated through SAML assertions, and all system communications are secured with certificate trust domain. This is the classic XDS environment that you see depicted here. That's what we've been based on. Once we had that document sharing exchange, we were hit with the problem of how do you federate multiple document sharing exchanges. One document sharing exchange could theoretically expand up to cover a whole region, but it's more likely that regions are going to be their own XDS environments. So we came up with cross-community access, which supports federation of document sharing exchanges. The other thing that this adds is it adds the ability for an EHR or some other clinical content system to be a participant as a whole community, even if it isn't inherently document-based or XDS-based, as long as it can support the document metadata model and provide retrieval of documents that it publishes as available. So now comes mobile health document sharing, and it is based on 100% FHIR infrastructure. It does have a document registry like XDS does. It does utilize the MHD transactions, but it also has persistence of the documents that are published inside of the FHIR infrastructure, and it does support lifecycle management of the documents. In this MHDS, we have also brought in patient identity management to support the full cycle of patient identities. support for OAuth-based authorization, support for consent management, trust framework based around certificate authorities and TLS, vocabulary management for value sets and potentially codes within the exchange, an audit record repository, and a provider and services discovery directory. So that was a lot of details around the 3 different models of document sharing without an explanation of the details of what is document sharing. So we're next going to go into the details of document sharing. So we start with the principles of a document. A document is based around these principles: persistence, stewardship, potential for authentication, context, wholeness, and human readability. These are important from a longitudinal perspective. These are important when it comes to reading a document that might be 10 or 20 or 30 years old. That's a particular important thing when it comes to a document exchange. So persistence. A document continues to exist in its unaltered state for a time period defined by local and regulatory requirements. Documents may outlive the technology that originally authored them. Again, we're looking at a longitudinal content around clinical treatment. So these documents might be needed 20 years or 30 years into the future. Stewardships. Document is maintained over its lifetime by a custodian, either the organization that published it or a person entrusted with its care, but there is a stewardship that understands the life cycle of the document and how long it needs to be maintained. A document is made up of an assemblage of information that is intended to be legally authenticated. So its completeness can be seen through its information around authorship and when and why. It has a context, so the clinical document in itself establishes the context for its contents. So this is a medical summary, this is a episode summary, this is a discharge summary, this is a lab result, with the context of why did it happen, where did it happen, who authored it, when did it happen, those kinds of context information. A document is also a whole unit of information. It's not a fragment, it's a whole unit. Parts of the document may be created or edited separately, but it may also be authenticated or legally authenticated as an entire document. It is treated as a whole unit. And then it is human readable. Even in some of the least human readable forms like XML, like a CDA document, the content, if opened up with just simple text-based technology, is human readable. So now that we have documents, the document sharing infrastructure that IHE has defines that there is a need for some kind of metadata about the documents. So for each document that's published or each document that's made available through a query, there is this set of metadata that is available describing that particular document. There's various reasons for this metadata: privacy, lifecycle exchange, descriptive, patient identity, and provenance. These reasons sometimes encapsulate the exact same element multiple times. You'll notice the author element is intended to be used for privacy and security, but also it's part of provenance itself, and it's very descriptive as to who authored this particular content. So you can see there are some elements that fall into multiple of these domains of information. But we have all of these information because some of them are critical to identifying the patient. Some of them are critical to how do I move the bits from one place to another. Within the document sharing infrastructure, there is a concept that the infrastructure is one thing and the content is what the infrastructure carries. Under all of the models, whether it's XDS or XCA or even the MHDS, they are all content agnostic, meaning I can carry CDA, I can carry PDF, I can carry FHIR, and it doesn't matter what the format of the content is that I'm carrying. It is content agnostic. The metadata is there to describe what the format is, what is the constraints around that format, who is the document about, why is the document published. We do support things like CDA and consolidated CDA, C32, FHIR documents, DICOM documents, PDF or text documents, even things as simple as JPEGs or TIFF. You've got a fax. You can index it with the document sharing infrastructure. And then there's some special formats, which are these on-demand formats and delayed assembly formats, for which I'm not going to go into much detail beyond this. So on-demand is just a document description says, I could create for you a medical summary, and when you ask for it, I'll create a fresh on-demand rendition of that medical summary. A delayed assembly is somewhat different in that the bits are not already pre-arranged, but the concept is whole, meaning something like a discharge summary. I could create a discharge summary, but when I create it, it's going to be the discharge summary. It's not going to be the current content. It's going to be the discharge summary that would have been produced at discharge. So that's a real high level on what document sharing is. Clearly it's more involved in that, but I wanted to give you a little bit of a background of what document sharing is. So now, how do I get to document sharing without all of this SOAP and EB registry? How do I get access to the document sharing using FHIR? So IHE produced mobile access to health documents. One of the early profiles that IHE produced actually was produced at the very same time that FHIR was coming into being, and its early rendition was just a JSON set of objects. That rendition became a part of the FHIR core. So the MHD profile itself is baked into FHIR as document reference and document manifest resources. The MHD profile has further constrained that for the purposes of document sharing versus all the potential uses that are envisioned inside of FHIR for document reference. MHD provides transactions to enable publication of documents or query and retrieve of documents, and then clearly the retrieval of the document content itself. The content isn't changed, but the way you access the content is. So the mechanisms you use to publish a document is FHIR-based. The mechanisms you use to query for documents is FHIR. The retrieve of the document is in whatever content was published, content agnostic. There are some options within MHD. There's some alternatives that constrain it even further to the set of metadata constraints that XDS needs. There is a looser set of constraints for minimal metadata. There is alternatives for push versus pull. There is the wiki article, goes into a little bit more details, and there's some other places I'll show you. The US core has the document reference now in it, and that document reference is intended to be aligned with the document reference that's in MHD. There is a superset alignment expectation there. So I earlier showed you the XDS diagram. You'll see it kind of in the middle there. And MHD as an API to XDS is shown with the gray bubbles. So on the left-hand side is MHD being used to publish documents. MHD document source publishes to a MHD document recipient. That's inside the profile. How you support it as an API is someone implements the MHD document recipient grouped with an XDS document source. And there's some open source implementations of this. And that just simply converts the publication request into an XDS publication request. The XDS infrastructure takes over from there. On the consuming side, a document consumer can use the MHD queries for document resources, query for document manifests, and retrieval of the documents. Some system has implemented the MHD document responder grouped with an XDS document consumer, and that proxies those queries and retrieves into the XDS environment. So this diagram is just showing how MHD can be an API to XDS. It's not the only use of MHD, but it is showing how if you have an XDS environment, you can add MHD support to that environment and therefore support MHD document sources or MHD document consumers. Similarly, I showed you XCA. I didn't show you this diagram in this detail, but essentially you can see on the right-hand side is a very similar story about supporting of MHD document consumers, talking to the MHD document responder, where the document responder is grouped with an initiating gateway, and there are some implementations of this. MHD is really just talking about the publication of documents, query and retrieve of documents. It doesn't talk about patient identity. There is 2 profiles available for that. PDQM, patient demographics query for mobile, and patient identity cross-reference for mobile. These provide the ability to look up patients by some identifiers or demographics, or to just do a cross-reference. Those profiles can be, again, an API to a PDQ or a PIX or an XCPD environment. So again, they could be an API interface to an existing infrastructure. There is an Internet User Authorization Profile, IUA, which is based on OAuth profile. This is a complement to Smart on FHIR, but it is looking at the same use cases for which the XUA profile was designed to support document sharing exchanges. So it's more document sharing exchange focused. There is updates to the ATNA profile, the audit trail and node authentication profile to support securing HTTP sessions and support for FHIR audit events. So similar functionality in the FHIR environment that you have in the classic XDS environment. And then there is the Mobile Care Services Discovery, MCSD, which is a provider directory, organization directory, health services directory, and this is a FHIR-based profile supporting access to organizations and endpoint definitions. So MCSD can be a proxy to HPD or CSD or PWP or any other UDDI-based management if you wish. So drilling quickly into MHD. MHD first transaction is provide document bundle transaction. It is the way that a document source requests that documents be published. This is mostly used with environments like XDS or MHDS that have the registry involved in supporting the publication request. It can be used to publish new documents, or it can be used to replace old documents or provide transforms, all of the mechanics of document sharing. But this transaction can also be used just simply to push a set of documents from one organization to another. So a RESTful push, HTTP post. It doesn't need to have overhead of things like email or again, the SOAP and EB registry. So the provide document bundle transaction is a bundle, FHIR bundle, made up of a document manifest, which explains why is this bundle existing, what is the create request wanting to do, and then a set of document reference resources and their binaries. The document is in a binary resource, and then there could be folders known in FHIR as a list, and depending on your context, like in a push, there might be a patient resource. So then, if we go over to the right-hand side, it's the query side, and in this case, these are just simple, normal FHIR queries. So a FHIR query against document reference. The patient query parameter is required because these are all patient-specific. But there's some other things like the class and the type and the practice setting and time frames that can help limit the number of document references that come back. And similar, you can query on document manifests. And then the third transaction, which isn't really described here, is just simply the retrieve of the document bits itself, the binary. So that was MHD. And MHD, as we saw, can be an API to XDS, it can be an API to XCA. But what if I want to have a document sharing infrastructure that's based only on FHIR infrastructures? Well, that's where MHDS comes in, Mobile Health Document Sharing. So this is functionally similar to XDS, except it's using all FHIR infrastructure. So in the central core is patient identity management, supporting creates and updates and merges and such. There's terminology repositories for the value sets that the community chooses to use. A provider directory or a care services directory, consistent time audit record repository. The trust framework is in that central infrastructure. And then in the center or the bottom, there's this document registry. An MHDS document registry is made up of an MHD document responder, supporting queries from document consumers, an MHD document recipient, supporting publication requests by document sources. It's using the patient identity consumer because it has to understand who is a legitimate patient versus who is a patient that shouldn't, doesn't exist. It has, of course, it's secure, and it's at a secure node. It has consistent time to support consistent time stamping of the last updated elements in FHIR resources and audit and such. It supports querying the value sets from the central value sets so that it can enforce metadata value sets. So the category of all documents can be within a particular value set for that community. And then it is, of course, enforcing IUA authorization determinations, and it's supporting consent decisions. On the left-hand side is systems that publish, and again, it's just an assembly of the profiles that we've talked about. And on the right-hand side, it's just the assembly of, again, the same profiles. But because there is a guarantee that these central infrastructure has these particular services, we can be far more deterministic that the systems that publish documents and the systems that consume documents can use a common terminology server. They can use a common patient identity manager. So whirlwind of discussion. Um, there are plenty more details behind this. This is just an introduction. IHE does publish FHIR conformance resources, capability statements, structure definitions, code systems, value sets, and examples. They're all up on the GitHub repository indicated there. We are implementing implementation guide publication packages, which would provide these in NPM package forms, which are common for FHIR-based implementation guides. Those are not yet available, but we are in the process of developing them. So I've shown you XDS, I've shown you XCA, I've shown you MHDS. So which infrastructure should you use? You've got three choices, IHE, and that's just unusual. IHE tends to give you exactly one solution. There still is some rather simple questions. Do you already have XDS in place? Do you have an infrastructure? If you do, then keep it. Probably add MHD as an API to that to support some clients that might be struggling to attach to XDS as it is today. The infrastructure is good quality infrastructure. If you already have XCA, again, keep your XCA, possibly add the MHD as an API to your XCA environment. The third question is, do you need a synchronous backbone? There are environments for which the backbone of an exchange, especially in a community or in an XCA environment, where the backbone can have high delays, and therefore having asynchronous capability is very important. If you have asynchronous backbone needs, you really need to use either XCA or XDS. If you need end-to-end security, meaning the document source secured all the way to the document consumer, the infrastructure cannot see the document content. If you have end-to-end security needs, then you need to look to XDS or XCA. And lastly, if you have document sources or document consumers that are XDS based, you kind of need to stick with XDS and XCA. And again, if you're sticking with those, absolutely recommend you add MHD as an API to those environments. So it's only if you have no current infrastructure that you should look to the MHDS. And that may seem like a small set, but there are certainly places that have not put any infrastructure in place yet. MHDS is a fine infrastructure to put in place, and MHDS can scale. It's not that it can't scale, it can start very small. Indeed, it could start based completely off of just one FHIR server. So everything I've said so far is about document sharing exchanges. So if we say, given that we have a document sharing exchange, how can we make consuming of the content easier? Can we support consuming of fine-grained resources instead of forcing the document consumer always? So MHD eliminates the need to understand SOAP and ABXML, and it provides this JSON or even simple XML as the infrastructure support. But it doesn't change the document content. It is content agnostic, but content preserving. Therefore, the content in the document sharing exchange could be DICOM, it could be CDA, it could be even CCR, it could be some other format. Those document contents are not necessarily easy to consume, especially if you don't know what format you're going to get. Even with something structured like CDA, which is XML, it's not simple XML. It's XML, but it's not a simple XML, and therefore it's difficult to parse through for a client. So what we're going to go into next is something that we think is better: consuming fine-grained FHIR resources, things like observations, allergy intolerances, immunizations, medications. And yet, we use the data that we'll eventually need to know the integrity and authenticity of the data. Meaning we provide the ability to get back to the document from which this information was derived. So it's not just a front end that provides observations that it has divined out of documents and won't tell you where did this observation come from. This solution we're going to talk about provides the provenance back to the original documents. So IHE has this query for existing data for mobile, QEDM profile. It is a very simple profile that supports FHIR-based queries against a set of FHIR-based resources, observations, allergy intolerance condition, diagnostic report. You can see the kind of set there. QEDM is aimed at supporting a class of system that wants to consume resources, but is also in this mobile space. It would really want to use maybe JSON and HTTP query, so it wants to use FHIR REST. That's what QEDM is all about, is just simply providing that. What we need to do is we need to marry QEDM way of accessing data with document sharing, which is a way of making data available. And that's what MXDE, the Mobile Cross-Enterprise Document Data Element Extraction profile, is intended to support. So it is a profile that defines how documents, given a document exchange, documents can be consumed, decomposed into their discrete FHIR resources with provenance back to the original document. So in this diagram on the right, you have the number one step is let's go and get all the documents for patient John Murky, because I just got a QEDM query on patient John Murky. Go get them all and decompile them into FHIR resources. That's what the gears is all about. So ultimately, the number two is I return the list of allergies that I divined out of that set of documents. But I also provided provenance. So step three, if this application wants to, it can invoke the step three, which is to look at the provenance resource and therefore do an MHD query to a document repository. Step three is an MHD query against document document references, and it can potentially pull the document itself in step four, and therefore you can have on the right hand side of the screen the patient summary that included a summary report with, on the left hand side, the list of allergies that came from QEDM. This is another rendition of the same thing. On the left-hand side, you have a set of document-based publications. EHRs and labs and EMRs are publishing various documents, and those are in the document repository. Some infrastructure in the center here divines out a set of observations, a set of medications, a set of allergies. And for example, here the green arrows are pointing that we found observation one within a medical summary, an episode of care, and a discharge summary. So on the far right, so you got FHIR resources in green. On far right, you have QEDM retrieving these observations and going, hey, tell me more about this observation one, for which you can see in the provenance that observation one existed in 3 different source documents, and it includes the definitions of those source documents. So this provenance is what really makes MXDE really useful. in that it doesn't add a lot of overhead to QEDM. You can just query for observations if you want. You don't have to look at the provenance, but the provenance is there if there's some reason to question the veracity or to follow up on, like, maybe a lab result. Hey, where was that lab result published? You can determine for any particular lab result how many documents was this published in, because there is a provenance for each document that was published in. And you can see that it was when it was decomposed out of that document, when it was, that it was done under this QEDM, and what the software was that did the decomposition. So, in conclusion, we have enabling technologies for FHIR accessibility of document sharing, be that a legacy XDS or XCA community, MHD as an API to that, or as a standalone infrastructure in MHDS. And we have provided the definitions and mechanics for how you decompose documents into resources so that they can be consumed more easily and yet get provenance back to the document source. So, if there's any questions, you can contact me by any of the mechanisms here. I can be reached at John Murky on Gmail, John Murky on Twitter, John Murky on Skype, or you may find some information on my blog at healthsecprivacy.blogspot. And I thank you for listening.